Thank you, Carl. All right, yeah. So, hi everyone. Some of you have seen me before. Some of you have actually even seen this presentation before, like he has, for example. So you might not have known that I will be presenting today, and neither did I until today. So this is quite fun. But this is a presentation that I actually did in a Microsoft Identity developer training that was held in Espoo at the Microsoft House a while ago. So that was pretty good. So I thought that I would do the same one for you folks. So as just a quick intro, my name is Joonas. I work as a developer and architect here at Azure. I'm one of the Azure MVPs along with Carl and Sakke here. If there's any developers in the room, you know Stack Overflow for sure. So I'm pretty active there. I also have a blog. If you're interested in Azure, like software development side, I blog relatively often. Not as often as I'd like, but I do. There's also a Twitter account if you want to follow me. I don't know why you would. I tweet out blog posts most of the time. So managed identities for Azure resources is the new name for this thing, and it is solving a kind of a specific problem. And that's the problem with secrets. Bless you. So most services actually that you might use databases, you might use a data storage service, anything, an API. Most of them use some kind of shared secrets or passwords so that your app can use that service, right? So it can authenticate. So the service knows who you are, right? So those things have some issues, mostly because that you have to actually protect those secrets. You have to make sure that they don't fall in the wrong hands. This can involve, for example, keeping those secrets out of code, getting them from elsewhere at runtime, so that you don't publish your secrets to GitHub, which a lot of people do, sadly. Like you can actually search GitHub for commits like remove password, and you'll find like thousands of them, which is sad. You also have to manage them, so you have to keep in mind always like, okay, how many of these do I have? What access do they actually have? Where are they? This kind of stuff that you just kind of have to do. When are they expiring? Because often they expire, and you have to remember to renew them before they do. And yeah, well, you'll find out if you don't. I have some experience with that. You also should remember to rotate them, right? So you should remember to switch them regularly. Like this could be twice a year or once a year or something, or even after like 2 or 3 months, you might want to switch. And this is just in case this secret has fallen into the wrong hands, it will no longer work after you have rotated it. So that's a good practice in general. You also may need to revoke them. So in some cases, you might be like, hey, okay, I really don't want this thing to be able to access this anymore, so remove access for this key. You might need to do that kind of stuff. And these kind of secrets often give you like blanket access, like just do anything. Azure Storage is a good example of this because you get 2 keys. And if you have that key, you can do absolutely anything in that storage account. You can create files, you can delete them, you can create queues, do anything, right? So the granularity is huge. And you can't tie this access to a single service, right? Because the secret isn't tied to like a client. It's tied just, to the storage account. So if you're using the same key from 2 services, yeah, both those services are using it, and it's not really tied to those services. So you can't remove access from one service, for example. If you revoke the key, both services lose access. Right? So this is kind of where managed identities comes in, because it's going to come in and solve all of those things. So this is a service that some of you might know as Managed Service Identity. This is what it was called before, MSI as well. That was problematic because Microsoft has other things which are called MSI. Yeah, acronyms are fun. So it has a few main features. It allows for automated service identity creation. Essentially, you just say, I want this identity for this service, and boom, it's there. It does key management and rotation for you. It's completely invisible to you. It will actually rotate keys within itself. It does the whole identity lifecycle management for you. So when you create a managed identity that's actually tied to a service in Azure, if you delete that service, the managed identity is also deleted at the same time. And essentially what this allows is that you can actually call Azure services with 0 credentials. That you don't actually need to store any secrets anywhere in the app, which is kind of cool. And it's available to you for the price of free. If you're not using this, I literally have no idea what to tell you. So there's 2 types. There's the system-assigned identity, which is tied to a service. For example, an Azure App Service. You can enable this, and an identity will be created that is specific for that app service. Will be deleted when the app service is deleted, right? Then there's also user-assigned identities. These are separate resources that you create in Azure. You can create these however many of you want, and then you can actually assign them to services. So you can share the same identity across services, or a service can actually have multiple identities if you want. So it just allows you that flexibility. The main reason user-assigned identities exist is for virtual machines that run containers. So each container can basically have its own identity that it uses. I prefer system-assigned identities usually, mainly because with the user-assigned identity, you have to take care of deleting that identity if you no longer need it, unlike with system-assigned. And I have a link here that you can check out, which has all the services that actually support managed identities. And so not all Azure services support managed identities. A couple that I would like to just highlight is App Service and Virtual Machines, for example. Those support them. And there's a few other ones as well. But do check that. So we don't have any secrets to worry about in our code or configuration if we're using managed identities. Essentially what happens there is that a local endpoint is created within the app service that basically your app can access only. It's a local access only HTTP endpoint that it can call and get access tokens. These access tokens are like temporary keys, right? It's a temporary permit for you to access some service. So yeah, no key rotation to remember. And the greatest one, in my opinion, or one of the great ones, is that you can get more granular access for your apps. It's no longer blanket access. You can actually say in storage that this one service should have a read access to this one blob container. So it's really, really granular. It kind of depends on services, how granular it can be, but it does allow it. It allows for better auditing. So essentially, because with the key, the only thing the service knows about the caller is, well, the key, right? They know they used this key. It doesn't tell them who called them, actually, at all. But with managed identity, the service actually gets a token that identifies the caller. So it actually allows for them to log which service did this thing, unlike with keys. Revocation can be done very quickly and very granularly as well. You can revoke access for one service immediately. So what some of the basic principles there, is that this is actually generating a service principal, which you can also think of as a service account. It's kind of like a user account, except it's for a service. It creates that in Azure Active Directory, which is connected to your Azure subscription. And then you essentially just need to grant access to this principal to the target service. And this access can be assigned at either the Azure Active Directory level or the service level, and the way that you do that kind of depends on the service. All the services do it a little bit differently, right? It's great. That was sarcasm. So some of the services that do support this method of authentication, so you can use managed identities, include, for example, the Azure Resource Management API. So you can get info on your Azure resources or create resources, do that kind of stuff. You can access Key Vault, which is the secret storage service of Azure, basically. And this actually allows for you to then store those secrets for those services which don't actually support this method of authentication. You can put those secrets in Key Vault and access Key Vault using a managed identity. And then you have, 0 secrets in your app. You can access all of these. And essentially, it's any service that allows for application permissions-based authentication with Azure AD, including your own APIs. So that's a little bit more difficult to set up, but it's possible. Now we get to the really fun part. So by the way, my slides are done. I don't really like slides. So I'm just going to write this URL here. So this demo is a little bit interactive. That is not going to be large enough for you to see. So I'm going to make it a little bit bigger. You can see that this demo app that I've made is a little bit old because it refers to MSI still. So it's a Joonas MSI tests.azurewebsites.net.
Best Zoom ever. Very manual.
Yes, very, very manual. So this is interactive. So if you have a laptop or a phone, it is actually responsive, the UI, which is kind of impressive for a UI that I made.
Good question.
Yes?
Can I somehow, do the setup of those identities as a description, not, for instance, as manual stuff, because
right.
It's always overlooked.
Yes.
Even in corporates, sometimes people
yes.
start to do it manually.
Yes. So the question was, can we do this in a more automated way instead of clicking in the portal to do this? Yes. The answer is yes. You can do this with ARM templates, for example, which is one way to describe infrastructure that you want to set up in Azure. And there are other ways. You can use the AZCLI, for example, to write scripts that do that. So there are multiple ways, essentially. Azure PowerShell also should work. And you can do all those kind of role assignments and all that with scripts, and most of them with ARM templates as well. So yeah, definitely automate it. All right, so here's the website, actually, the small web app that I've made. So the point of this web app actually is to just showcase access to a number of different Azure services without using any credentials anywhere in the app. So using purely the managed identity that it has. And I can actually show you one thing first. So if I go here to Azure and open my app service here, I'll show you how to enable this managed identity from the Azure portal. You're going to have to follow me very closely, I know, because this is a little bit difficult. So on the left side, we can find identity. So the icon is very similar to authentication authorization, but yeah, that's not the correct one, it's identity. Now, then you would come here, click this switch here to on, then click save. You're done. I know that's difficult, but I believe that you can do it. So here also are the user-assigned identities, by the way. So if you wanted to assign those identities that you create separately, you can do that here. I don't have any. I only have a system-assigned identity. So the first one here is Key Vault, which is one of the cool ones, because what it showcases here in the app is actually using Azure Key Vault as a configuration provider for the app. So it essentially really invisibly uses Azure Key Vault to get configuration data for the app when it starts up. So it essentially gets its configuration from Key Vault. And this value here is actually stored in a secret in Key Vault, which allows for you to, store all those API secrets and stuff if you need those. And then we have Azure Storage. So this is actually reading a file from Azure Storage. And then we have a call to an Azure SQL database, which is also authenticated with this without no passwords, no nothing. Then we also have a Azure Data Lake, which is kind of the same as blob storage, just for a different purpose. So again, reading a file. Then we have a custom API, which is kind of cool. So this is calling an API in a separate app service that I have made. And it's authenticating using the managed identity. So that's kind of cool. So this is just showcasing some of the facts that that API is receiving when it is called by the managed identity. So you can see there's, for example, the app ID, which identifies that identity, basically identifying the caller. But now we get to the fun demos, actually. We have a couple messaging demos. So under Service Bus Queue, there's a send and a listen. So the listening page is actually real time. So if you send a message, it will show up here. So if you press the button, everyone who is on this page is going to receive it real time. And so now, as a kind of a load test, if you could just please click on that send button as many times as you can, and we will see if the app crashes. It's performing pretty well for now. Hasn't crashed yet. I can see that the TV is actually lagging a little bit. Okay, that's really good. Thanks. The fact that it didn't crash is pretty positive. I also have the same thing for an Azure Event Hub, which is really the same demo. It just sends a message to an Event Hub, and that's received here. Now, Event Hubs are a little bit different from Service Bus Queues, with the ability to ingest massive amounts of data, like millions of messages per second. And yeah, you can see the scale is a little bit different for an Event Hub. Yeah, because it's receiving them in batches. So that's pretty cool. And the fact that my app didn't crash yet is pretty positive. Thank you. Thank you for the load test. So in this case, it's actually sending a message to this queue or Event Hub, and the same app, a background service within the same app, is actually receiving it, which is kind of a stupid thing to do, right? Why am I sending a message just so that I can receive it? Well, I mean, it makes for a simpler demo, I suppose, instead of building a third thing there, in addition to the app and the API. Yeah. So all the source code is available for this, by the way. So the main page here has a link to GitHub to all the source code for this. It also has guidance for you if you want to set this up yourself. There's a bunch of instructions for how to set up, blob storage access and all that. All right, that's actually it for the main content of my presentation. So now I have some time for questions. Any questions? Yes?
I'm just wondering, maybe you can tell a little bit more in the basic detail. Suppose I have a service that make a REST call to other service. How does it work below the hood? And if I'm calling like the URL, I don't use any keys and whatnot.
Yeah.
How it's handled and how it's achieved that somebody else calling this URL will not gets access.
Okay, yeah, sure. So
What happens between those two services in the
yeah.
texture?
So the question was mainly just about like what happens, basically what happens between my app and this service.
Okay.
Basically, like how the flow works, right? This is where you're going to see my amazing drawing skills. So let's assume, for example, that the service is an API that we've made. Just as an example, honestly, it doesn't matter. So we have an API, and then we have our app, right? So now if I just assume that this is running within app service, and I'll make that as a second box around it. Then what actually happens when you enable that identity is that a service principal will be created in Azure AD, in your Azure AD tenant, your Azure AD instance. And so we'll have a service principal there, which actually has a key registered automatically for you in the background. And that's not something that you need to worry about. That's something the system worries about. It's actually a certificate. It's a key pair, right? It's a public-private key pair. So the public key is actually added here. And then what happens also is that there's going to be this managed identity endpoint within your app service instance. So this endpoint here is not something that outsiders can call. So this can only be called from here. So once you want to access that service, your app is actually making a call, an HTTP call to this endpoint. It's saying that I want an access token for my API. You have to identify what you want the token for. And essentially what managed identity in the background is doing is it's asking for that token from Azure AD.
And this is transparent to me
Yes.
when I try to call.
Yes, it's completely opaque to you, like you won't see this. So you get back an access token, and this is then returned to your app, to your code. And now that we have this token, we can then call our API. So you make your call and you attach that access token with the request. It's typically attached as an HTTP header. And then now your API is going to validate that token. Your API is going to do certain validations to that token. And I think that the whole process of token validation, JSON Web Tokens, is a little bit out of scope for this. But trying to summarize it, when this API starts, it's actually loading some metadata from Azure AD. And this metadata includes public keys that Azure AD uses to sign its tokens. And then basically when it receives this access token, this API can by itself verify that this token has indeed been created by your Azure AD, and it can check other things. It hasn't expired, etc., etc. And if it considers it valid, it will return a response to you.
And when API is being called, there is also some sort of other outside box that takes care of this, right?
Here, no. So this is the whole process, actually. So in order to validate the token, the API doesn't need to make any calls anywhere. It already has everything it needs.
Azure API
Yeah, but for the process for an Azure API is the same. They do the exact same thing. There's no difference for what they do. But then, of course, then how you do authorization from that point, of course, that depends on your API, that depends on the Azure service, etc., etc. So with, I can actually show you how it looks like, for example, with Key Vault. So I have my Key Vault here that it's calling. And with Key Vault, you actually have to set up an access policy So here you can see that my application here has certain access to this key vault, and here I can actually verify what access it has. So it has secret management, get, and list. So it has read access, for example. But the way that you set this up depends on the service, right? So for key vault, it's like this. And for other services, it's different. I have some blog posts on these, by the way, if you check them out. But thank you. That was a good question. Anything else? Oh, hey, yeah.
So I'm assuming it requires either owner or user's access administrator role for the person enabling the identity.
To enable the identity on a service, I do believe you only need contributor rights on that resource.
The contributor does not have
well, you can't give access then, but you can still generate the identity for the resource. Like if I can go and toggle the managed identity to on for an app service, and that'll generate the service principal, but it won't have any access by default to anything. So in order to give that access to, for example, Key Vault, I'm going to need permissions on Key Vault to do that. Like I can't do that otherwise. Okay? Yeah.
Yeah, how do we deal in a situation when we have on-premise Active Directory and we would like to integrate it with Azure AD? How do we manage the identities like those cases?
Yeah, well, on-premises AD and Azure AD integration is, well, it's a little bit out of scope here, and honestly not even my expertise. But the way that you do that is that there's this program that you install on-premises, and then that will basically synchronize the identities to Azure AD. But managed identity is purely an Azure AD capability and not an on-premises capability.
Do you need any permissions on the Azure AD side?
Yep. No. On Azure AD, you do not require any special role to set up those service principals. So I do have heard that in some larger organizations, they have thousands of service principals as a result, and they're like, okay, so who created this and what it's for? And I have no idea. I have given some feedback to the Azure team responsible on that.
Well, isn't there the option that you can disable users creating those in your Azure AD? So
well, yeah, so you can prevent users from generating apps or registering apps in Azure AD. I don't think it applies to this, but or have you tried this actually? I mean, I could be wrong.
combo, but
Yeah, that's an interesting question. That because in Azure AD there's a toggle that basically says normal users can't register apps, right? So if that's on, would it be possible to still create these? And the answer is, I think it should still be possible, but honestly, I'm not 100% sure.
So in that sense, an app registration is pretty much creating
Because yeah, because the thing is, it's like you are not technically creating the service principal. It's the Azure's resource provider there in the background which is doing it. So it might not be acting on your behalf, actually, for that. Not sure, honestly. Okay, more questions? Or do you want to get to the labs? Okay. Then let's go ahead to those. Thank you.